Hello, students. I am Swayam, currently pursuing my MBBS at AIIMS Bhubaneswar. Okay. So we have completed atomic structures chapter previously. So we are starting with chemical kinetics today. There are 35 questions in this chapter. We'll divide it into 18, 17 or 17, 18. We'll complete it in 2 days. Okay. So let's start the chapter. Uh, Question number one. The rate constant for a first order reaction is 4.0606 into 10 to the power minus 3 per second. The time required to reduce 2 gram of the reactant to 0.2 gram. So the question is asking the time required to reduce the 2 gram of the reactant to 0.2 gram. What is given in the question? Rate constant. The rate constant is given as 4.606 into 10 to the power minus 3 per second. We need to calculate the time required for conversion of 2 gram reactant into 0.2 gram. So here A naught means the initial concentration is 2 gram. A means the end concentration is 0.2 gram. For the first order reaction, we use the integrated equation. Which integrated equation we use? That is ln A naught divided by A is equal to KT. If we convert ln into log 10, then it will be 2.303 into log 10. Here A naught is 2 gram and A is 0.2. The rate constant K is given as 4.606 and into 10 to the power minus 3. 4.60, just a minute, equals to 4.606 into 10 to the power minus 3 into t. We need this time. So time would be 2.303 log 10. Here 0.2 cancel out 2 by 10 log 10 of 10 divided by 4.606 into 10 to the power minus 3. Here 2.303 cancels out 4.606 by 2 and log 10 of 10 value is 1. Okay. So the time would be 10 into 10 to the power 3 divided by 2. That would equal to 10 to the 4 by, sorry, here 1. It is not 10, it is 1. Okay. So 10 to the power 3 divided by 2, 1000 by 2, that is 500 seconds. So the time required to convert 2 gram of the reactant to 0.2 gram would be 500 seconds. Okay. So let's move on to second question. For the reaction N2 plus 3H2 gives rise to 2NH3. dNH3 by dt means instantaneous rate of reaction would be 2 into 10 to the minus 4 mole per liter per second. The value of minus dH2 divided by dt would be. Okay. So for a reaction, sample reaction I'm giving, how to calculate the rate of reaction. Let's suppose a elementary reaction. Elementary reaction is given as A plus B equal to C plus D. Rate of reaction in a layman language would be the production of product with respect to time and consumption of reactant with respect to time. But in the rate law equation, we write differently. Let's see how. A plus B gives rise to C plus D. If we need a average rate of reaction, it would be written as minus del A divided by del T equal to, it is a rate of, okay, rate can be expressed in terms of A, in terms of B, in terms of C, or in terms of D. So in terms of A, it would be minus because it is decreasing in amount. Del A would be negative. Okay, here it will be negative. So if we put negative sign here, this will cancel out this negative sign and it will convert it to positive because rate can't be negative. Okay, so rate minus del A by del T. For reactant part, we put a extra negative sign before the del A by del T. Then it would be minus del B by del T. But for product, we don't need to put the negative sign because product is formed. So del C would be positive value. So del C by del T, del D by del. Okay, it is the average rate of reaction. But if we need the instantaneous rate of reaction, and there are some coefficient before the reactant or product, how to write the rate of reaction, we'll see here. Let's suppose the reaction is A, A, B, B gives rise to C, C plus D, D. Okay, so their instantaneous rate of reaction would be minus dA by dt. But here we need to put the A in the denominator part. Okay, 1 by A. The coefficient would be placed in the denominator part. Okay, so equal to the rate equal to minus dA by dt, then minus dB by dt minus C, sorry, minus dC. It is product, so no need to put the minus sign, sorry. Okay, dC by dt, 1 by C, 1 by D, dd by dt. So the for instantaneous rate of reaction, it is the form. Here it is given N2 plus 3H2 gives rise to 2NH3. So let's write the formula for it. This reaction N2 plus 3H2 gives rise to 2NH3. So the rate of reaction would be minus d N2 divided dt is equal to 1 by 3 minus 1 by 3 dH2 by dt 1 by 2 dNH3 by dt. Okay. So given information is dNH3 by dt is 2 into 10 to the minus 4 mole per liter per second. It is asking the value of minus dH2 by dt. Let's equate these two equations. 1 by 3 dH2 by dt is equal to half of dNH3 by dt. So dH2 minus dH2 by dt would be 3 by 2, the value of dNH3 by dt. dNH3 by dt is given as 2 into 10 to the power minus 4. So 2 cancels out. It is equal to 3 into 10 to the power minus 4 mole per liter per second. So the answer would be option D. Okay. The rate of disappearance of hydrogen. Okay. So let's move on to next question. Similar question. BRO3 minus plus 5Br minus plus 6H plus gives rise to 3Br2 plus 3H2. Okay, let's write the equation first. 5Br minus 6H plus gives rise to 3 bromine plus 3 water. So how to write the equation? We'll write rate of reaction would be minus dBr03 minus dt minus 1 by 5 dBr minus by dt equal to minus 1 by 6 dH plus by dt equal to 1 by 3 dBr2 by dt. Okay, so it is asking the relation between rate of appearance of bromine and disappearance of bromide ion. So let's equate these two terms. Okay, so minus 1 by 5 dBr minus by dt is equal to 1 by 3 dBr2 divided by dt. If we solve this, dBr2 by dt would be equal to minus 3 by 5 dBr minus by dt. So it will be the final form. So the relation between bromine and bromide ion would be option number D. Okay, so the option D is the correct. So question number 4. For the reaction 2A plus B gives rise to 3C plus D. Which of the following doesn't express the reaction rate? Okay, let's write the reaction rate. Okay, 2A plus B gives rise to 3C plus D. The reaction rate in terms of A, B, or C. Okay, it would be minus half dA by dt equal to minus dB by dt or my plus 1 by 3 dC by dt or d by dt. Okay, so in the option minus dB by dt, okay, it is there. Dd by dt, it is also correct. Minus half dA by dt, it is also correct. Minus 1 by 3 dC by dt, but it would be plus 1 by 3 because it is in the product side. So option D is incorrect because it has a negative sign instead of a positive sign. Okay, so D option is incorrect. Let's move on to question number 5. A first order reaction has a rate constant of 2.303 n into 10 to the power minus 3 per second. The time required for 40 gram of this reactant to reduce to 10 gram would be given log 10 value of 2 is 0.301. Okay. In the question, the information given are the rate constant. Rate constant for a first order reaction. The rate constant given is 2.303 into 10 to the power minus 3 per second. The time required for 40 gram. Okay. Here, A naught is the initial concentration. Okay, it is A naught and the final concentration. is A. That is equal to initial is 40 gram and finally we reach to 10 gram. Okay. Let's put the integrated equation of first order reaction. Ln A naught divided by A equal to KT. If we convert ln into log 10, it would be 2.303. A naught is 40 and A is 10, equal to K is given as 2.303 into 10 to the power minus 3 per second into time. So 10, 10, 2.303 log 4 into 2.303 into 10 to the power minus 3 into t. 2.3033 cancels out. If I have to find out log 4, we will convert 2 into log 2 equal to 10 to the power minus 3 into t. 2 into log 2. Log 2 value is 0.301. And then 10 to the power minus 3 is equal to time. So the time is 602 seconds. Okay. So if you have to calculate the time, simply remember this equation. You'll simply get the answer. What is the alternative way of doing this problem? Alternative would be by the method of T half. Okay. By the method of T half or half life. Okay. So the concentration was 40 initially. Then it would be converted into half, that is 20 gram, and it would be converted into 10 gram. Okay. For first order reaction, the T half doesn't depend on the initial concentration. Okay. For each half reaction, it would take the same time. Means for the conversion of 40 gram to 20 gram, if it requires time T, for 20 gram to 10 gram, it will also require time T. Okay. So let's find out the T half. For T half of a first order reaction, the formula is 0.693 divided by K. T half for this reaction equal to 0.693 divided by 2.303 into 10 to the power minus 3. It would be around 300.91 second. Sir, for T half, the value is 300.91 second. In this reaction, 2 T half is required. Okay. For 40 gram to 20 gram conversion, 1 T half, and for 20 gram to 10 gram conversion, another T half. So the total time would be 2 into T half. Okay. So 2 into T half equal to 300.91 second. It is around 602 seconds. So in this way also you can calculate by calculating the T half. Okay. So let's move on to next question. Question number 6. When initial concentration of the reactant is doubled, the half-life period of a zero order reaction. Okay. Look, there are three types of reaction: zero order, first order, and second order. For zero order reaction, the T half is directly proportional to the initial concentration. For first order reaction, T half is not related to A naught. Okay, it doesn't depend upon the initial concentration. So it is a constant. Okay, it is a constant. Here, for first order reaction, it doesn't depend upon the A naught. For second order reaction, T half is inversely proportional to A naught. Okay, what does that mean? Means for zero order reaction, if you increase the amount of the initial concentration, if you increase the initial concentration of the reaction, the T half will also increase. For first order reaction, if you will increase the initial concentration, the T half would remain constant. It only depends upon the value K, means rate constant. For second order reaction, if you increase the amount of initial concentration or initial concentration value, then T half would decrease. Okay. So what is the exact formula for T half for first order reaction? It is A naught by 2K. For first order reaction, it is 0.693 divided by K. And for second order, it is K N. Okay. So let's write down the unit also. Uh, it is second, and second. As it is a T half, it is time. Okay. So when initial concentration of the reactant is level, the half-life period of a zero order reaction. So zero order reaction, we know that T half is directly proportional to initial concentration. If the initial concentration is double for zero order reaction, the half-life will also be double. So the answer would be option B. The T half is double. Okay. Let's draw the graphs also. T half and initial concentration graphs. For zero order reaction, concentration and T half. For zero order reaction, it would be a linear increasing graph. Okay. For first order reaction, it would remain as constant value 0.693 divided by K. For second order reaction, it would be a decreasing curve. Okay. Concentration in T half. You have to remember the formula, you have to remember the relation, and you have to remember the graphs. Okay. So let's move on to question number 7. If the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by. Okay, given is rate constant K. Let's assume the initial concentration is A naught and the final concentration is A. Initially, it was 100. Now it is completed by 99%. Means the remaining concentration is only 1. Okay. Many students put the A value as 99. Okay. They do not understand that it is the completed portion. But we have to calculate by taking the remaining portion. That is A is equal to 1. So let's put the formula. What's the formula? 2.303 log 10 A naught divided by A equal to KT. 2.303 log 10. A naught is 100. A is 1 equal to KT. 2.303 log 10 of 100 is 2. It is equal to KT. So time would be 4.606 divided by K. So the time required for the completion of 99% of the reaction would be 4.606 divided by K. Okay, let's move on to next question. We were moving on to next question. We'll write the integrated formula for different order reaction so that you will find it easy for remembering the formulas. Okay, so for zero order reaction, it would be A naught minus A is equal to KT. For 1 degree, we are using 2.303 log 10 A naught by A equal to KT. For second order reaction, it is K equal to 1 by T, or write this down, is 1 by A, 1 by A naught equal to KT. Okay, you need these three equations. Okay, so let's read the eighth question. Mechanism of a hypothetical reaction given is x2, y2, giving rise to 2xy. But it is not a elementary reaction. It is a complex reaction. It is a multi-step reaction. The first step of the reaction is x2 gives rise to x plus x. That is a first reaction. Then x plus y2 giving rise to xy plus y. It is a slow reaction. Then third reaction is x plus y giving rise to xy, and it is also a fast reaction. Okay. In this condition, how will you find the order of the reaction? Let's find out what is order of a reaction. If a reaction is given as A plus B giving rise to some product. Okay. Then rate of the reaction would be here. Rate of the reaction will be proportional to A to the power A and B to the power B. It is based on mass principle. Okay. But according to rate law, it would be A to the power X, B to the power Y. Okay. And these A and X and B and Y maybe sometimes are equal or maybe different. Why? Because of the complexity of the reaction. If it is a elementary reaction, it would be x equal to a and y equal to b. If it is a complex reaction, it won't be the same. Let's find out for this reaction 1, 2, and 3. For complex reaction, we have to consider the slowest step reaction for the for finding out the order of the reaction. In these three equations, which is the slow step? Equation 2 or reaction 2 is the slowest step. So the rate of reaction would be determined by the second step of the reaction. The second step of the reaction is x plus y2 giving rise to xy plus y. So rate would be k into x into y2. Okay. So from this we are finding rate of the reaction, order of the reaction is 2. Okay. Order of the reaction is means the summation of superscript of the rate law. Okay. So from this equation, we are getting order of the reaction 2. But in the final reaction, x2, y2, and 2xy. There is no here x can be found. Okay, so we have to convert this x in the form of x2. How can we convert this? Let's assume the first reaction, that is x2 equal to x plus x, is a reversible, fast reversible reaction. Okay, so equilibrium constant would be k equal to x into x divided by x2. K equal to x square divided by x2. So x square equal to k x2. X would be k x2 to the power half. So x is converted in the form of x2. Let's put the x value here. Okay. What is the rate given? Rate is equal to k ax y2. From the equation we got k x value is x2 half y2. Okay. This is the final form of rate of this reaction. From this we can get the real value of order. So order of reaction would be summation of superscript of the rate law. So half plus 1, that is 1.5. So the answer would be C. Okay. So let's move on to next question. Question number 9. A first order reaction has a specific reaction rate of 10 to the 1 minus 2 per second. How much time will it take for 20 gram of the reactant to reduce to 5 gram? So given is K, rate constant given 10 to the power minus 2 second per second. The initial concentration was A naught is equal to 20 gram. The final concentration is A equal to 5 gram. So the equation would be 2.303 log 10. As it is a first order reaction, A naught divided by A is equal to KT. So 2.303 log 10. A naught is 20, A is 5. K is given as 10 to the power minus 2 time. Then 2.303 log 10 of 4 is equal to 10 to the power minus 2t. 2.303 log 4 is, let's convert it into the 2 form. 2 log 10 2. 2.303 into 2 into 0.30. Let's put 30, 10 to the minus 2t. So time would be 2.303 into 0.6 divided by 10 to the power minus 2. Okay, it would be nearly 6. Let's calculate here. It would be 1 38.6 seconds. Okay. So the answer would be option A. Question number 10. The rate of a first order reaction is given as 0.04 mole per liter per second at 10 seconds and 0.03 mole per liter per second and 20 seconds after initiation of the reaction. The half-life period of the reaction. Okay. So it is given that after 10 seconds, it is a first order reaction. Okay. After 10 seconds, the rate is 0.04 mole per liter per second. After 20 seconds, it is 0.03 mole per liter per second. Okay. So the rate would be, let's write in this way. K is equal to, this is a formula for the this type of question. There is a formula called K equal to 2.303 T2 minus T1 log A minus x1 divided by A minus x2. Okay. So here K is equal to 2.303. T2 means 20 seconds. T1 means 10 seconds. Log 0.04 divided by 0.03 is equal to 0.6932 divided by T half. K is converted in the form of T half, 0.693 divided by T half. Okay. So it would be 2.303 into 0.1249 divided by 10. So after calculating, T half would be 6.693 into 10 divided by 2.303 into 0.1249. The answer would be 24.1 second. T half. Okay. So the answer would be A. Question number 11. When the initial concentration of a reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction. Okay, I told you for zero order, the half-life is directly proportional to A naught. For 1 degree, 1 order, well, first order, it is T half independent of A naught. Okay, that is A naught to the power 0. For second order, it is reverse. That is T half is directly proportional to 1 by A naught. Okay. In this question, it is given that after changing the initial concentration means changing into double. Okay. After doubling the initial concentration also, the half-life is not affected. That means the half-life is independent of the initial concentration. In which order reaction half-life is independent of the like initial concentration? It is first order reaction. Okay. If it was given like if you double the concentration of reactant, the rate of reaction is also doubled, then it would be zero order reaction. Okay. But here it is 1D like first order reaction. So the correct option is A. Question number 12. A reaction is 50% completed in 2 hours and 75% completed in 4 hours. The order of the reaction. Okay. Like if initial concentration is 100, it is converted into 50 in 2 hours. Then it is converted into 70. It is completed by 75%, means it is converted into 25. Okay. So it takes 4 hours. That means from 50 to 25, it would take 2 hours. Okay. Notice from 100 to 50, it is okay. It is converted half. From 50 to 25, it is also converted half. Means these are the T half. Okay. If both the T half are same, that is equal to hours, despite of changing the initial concentration, that is in this situation it is 100, in this situation it is 50. Despite changing the initial concentration, the T half remains same, that is 2 hours. So what would be the rate order of the reaction? It is the T half is independent of the initial concentration, means it is a first order reaction. Okay. So correct option is B. Let's move on to question number 13. For a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. The concentration of both A and B are doubled. The rate will increase by a factor of. So let's write down the rate law first. So the rate law would be, rate of the reaction would be K. With respect to A, the order is 2. So the superscript will be 2. For with respect to B, it is 3. So superscript will be 3. Okay. So now the question is saying that both A and B concentrations are double. That means it is R dash. The concentration of A is double, 2A square. The concentration of B is also double, that is 2B cube. So the 2 square would be 4K. Okay. And here 2Q would be 8B. Okay. So 4 into 8, that is 32. So the R dash means the new rate would be 32 times that of the first rate. Okay. So let's go to next question. I'm writing this clearly again. 4K, that is A square, 8P cube. And 8 into 4 equal to 32. A to B cube. This K, A to the power 2 and B to the power cube is R, 32 R. So the R dash would be 32 times of the initial rate. Question number 14. In a zero order reaction, for every 10-degree rise of temperature, the rate is doubled. Okay. Let's suppose the initial temperature is 0, then it is increased to 10 degrees Celsius. If here the rate is R, it would be it would be doubled in 10 degrees Celsius. So it is 2R here. If the temperature is increased from 10 degrees Celsius to 100 degrees Celsius, the rate of the reaction will become. Okay. So how many times it would be doubled? Let's find out the 0 to 10. 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 degrees Celsius, 70 to 80 degrees Celsius, 80 to 90 degrees Celsius, and 100 degrees Celsius. Okay, but it is starting from 10. Okay, so here it would be doubled, here it would be doubled, here also, then 2, 2, 2, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be doubled 9 times. Means 2 to the power 9 times. Okay. So rate of reaction would be R naught. Initial rate into 2 to the power 9. That is, what is the value of 2 to the power 9? It is 5, 1, 2. So the final rate would be 512 times of the initial rate. Okay. So the option B is correct. Okay. So let's move on to next question 15. Which one of the following statements for the order of a reaction is incorrect? For the let's read one by one. Option A is saying order can be determined only experimentally. Yes, order can't be determined by just writing the equation. Why? Because many reactions are complex reactions. Okay, they are not a single step reaction or elementary reaction. Like we saw in the reaction of XY2 and XY. Okay, like that reaction, many reactions are complex reaction. We can only determine the order of the reactions by experimentation. Okay, in those types of reactions, we can't write key x plus y2 giving rise to xy plus xy. If it is a complex reaction or multi-step reaction, we can't write it as r is equal to k x to the power 1 or y to the power 1. It can be x half and y2 3 by 2 also. Okay, we can't determine from this step only. We have to go through the slowest step of the reaction. So the order can be determined only by experiment. Okay, so the option A is correct. Order is not influenced by stoichiometric coefficient of the reactant. It is also correct because it is not, if you write 1 and 1 here, it is not a hard and fast rule that the order of the reaction would be x to the 1 and y to the power 1. It can vary. It can become -1 also. It can become plus half also. Okay. So the stoichiometric coefficient doesn't determine your order of the reaction. Okay. So option B is also correct. C. Order of reaction is sum of power to the concentration of terms of the reactant to express the rate of reaction. Yeah, it is. It is correct because if we write rate law, if the concentration term has superscript A and concentration P term has superscript B, so the order will be A plus B, the summation of the power. Okay, so option C is also correct. Option D, order of reaction is always whole number. No, it can be a negative number, it can be a fraction, or it can be a zero. It is not always a whole number. Like example, let's suppose the reaction of ozone. Ozone is breaking down into oxygen. Okay. The balanced equation will be 2O3, 3O2. You might guess like the rate of reaction would be KO3 into to the power 2. No, it is not correct. What will be the rate of reaction? By experimentation, we know the rate of reaction of this reaction would be K into O3 square and O2 minus 1. Okay. So what is the rate order here? It is also 2, like 2, and it is also minus 1. So the final order would be 1. Okay. Previously we saw in that x plus y2, x2 plus y2 giving rise to xy. What was the order of that reaction? It was 1.5. Is it a whole number? It is a fraction. So order can be, I'm writing here, order of a reaction can be negative, positive, or 0. Okay. Or fractions also. So let's move on to question number 16. So, so for zero order reaction, put n is equal to 0. It would be mole per liter L minus 1, 1 minus n, that is minus 1. So mole per liter per second. This is the unit of rate constant for a zero order reaction. Okay, let's find out. So option number, like option A is correct. But let's find out the unit for first order reaction also. Put n equal to 1 here. That is mole per liter 1 minus 1 per second. Mole per liter to the power 0 is second. Okay. So here it would be 1 into second. So for first order reaction, the unit of the rate constant would be only per second. For second order reaction, mole per liter 1 minus 2. N value is 2 here per second. Means mole per liter minus 1. That means mole inverse mole to the power minus 1 liter to the power minus 1 and 6. Okay. So option A is correct here. It is for second order reaction. Mole per liter to the power minus 1 means it is molarity. So let's write this way. Molar inverse per second. Okay. So let's move on to final question of today's session. During the kinetic study of the reaction 2A plus B giving rise to C plus D, following results are obtained. Okay. What are the results? For the first run, the concentration of A was 0.1, concentration of B was 0.1, 0.1, 0.1, and the rate is 10 point minus 6 into 10 to the power minus 3. Based on the above data, which one of the following is correct? Means it is asking us to find out the order. Okay, let's see this way. 0.1, 0.1, it was a concentration, initial concentration of A and B. Let's focus on run IV. Okay, here we increase the concentration of A to 0.4 and B remains constant. Means A increased 4 times. Okay, here it is converted into 4.2.4 into 10 to the power minus 2. Means 24 into 10 to the power minus 3. If we increase the amount of A, the concentration of A by 4 times, the rate of reaction also increases 4 times. What does that mean? Means the superscript of A, that is, let's suppose the superscript of A is X in the rate law. If it is increased four times, okay, the A is increased four times, then rate also is increased by four times. Means the superscript would be 1. Then only 4 to the power 1 would be 4. So the superscript of A is determined as 1. So A to the power 1. We got the superscript of A. For B, let's look here at uh, look at any of the 2 and 3. Let's suppose 0.3 and 0.2. Convert it into 72 into 10 to the power minus 3. Okay. We know the superscript for A. So if we increase 3 times, if we increase A by 3 times, the reaction rate would be increased by 3 times. So it would have been 6 into 3, that is 18 into 10 to power minus 3. But here it is written 72. So how much time we have to multiply 18 to get 72? 18 into 4 is 72, right? So it all depends on B concentration now, because we got 18 by multiplying 3 for the increase in A concentration. So rest of the increment will be dependent on B. Okay. So B is doubled. B is doubled. But the rate of reaction is quadrupled. That means, what does that mean? Means the superscript for B, let's suppose Y, if we increase it to 2B, it is increasing the rate by 4 times. That means the superscript would be 2. Okay. Then only 2 to the power 2 would be 4, and the reaction rate would be increased by 4. Okay. So we are getting the rate of the reaction would be finally K A to power 1 and B to the power 2. So option D is correct. Okay. So let's end this here. We'll look 18 question tomorrow. Till then, revise the concepts, revise the formulas of this chapter. Okay. Thank you.